Hi, this is Jeff Spence, your Math 120 instructor for the Community College of Denver, and this is our video lecture over Section 10A, Fundamentals of Geometry. So we're going to be looking at a lot of different things about geometry. We're going to be looking at lengths, areas, volumes, things of that nature. So, points, lines, and planes. So a point is just a particular point in a plane. It's imagined to have zero size. A line is formed by connecting any 2 points to a straight line that goes on forever and ever. And line segments are just pieces of a line, like maybe from this point to this point. And then a plane is a perfectly flat surface that has infinite length and width but no thickness. So like a piece of paper or the wall is a plane. It has 2 dimensions. The dimension of an object can be thought of the number of independent directions in which you could move if you were on the object. We also think about dimension as the number of coordinates required to locate a point. So one dimension is just, 1 point along one axis. Okay, so in one dimension we can only go one way or the other. In 2 dimensions we have two coordinates to match up to that point. We have the x and y plane. And then here we have a 3-dimensional plane, which is what we think we live in the world. It's a 3-dimensional world. We can go left, right, up, or down. That gives us 3 different options, 3 different coordinates to mark our position in the world. Angles are the intersection of 2 lines or line segments. The point of intersection is called the vertex of the angle. We have types of angles. We have a right angle, which measures 90 degrees, a straight angle, which is 180 degrees, an acute angle measures less than 90, and an obtuse angle measures between 90 and 180. Find the degree measure of the angles that subtend or span a semicircle, half of a circle. So remember, a full circle is 490 degrees, so it's 360 degrees in a circle. So a semicircle would be half of a circle. That would be 180 degrees. The angle that subtends a quarter circle is just 1/4 of a circle, so 1/4 times 360 is 90 degrees. The angle that subtends or spans an eighth of a circle, you just do 1/8 times 360, it's 45 degrees. An angle that subtends 100th of a circle, we just take 1 divided by 100 times 360, it's 3.6 degrees. Plane geometry is the geometry of 2-dimensional objects. So we're going to look a lot at plane geometry type of stuff, areas and perimeters. So all points on a circle are located at the same distance from the radius. All points on a circle are located at the same distance, the radius, that distance, from the circle's center. So that's the radius, and the diameter is all the way across through the center. So another way to think of the diameter is it's twice the radius. So the perimeter of a plane object is simply the length around its boundary. We can find the perimeter of a polygon by adding the lengths of the individual edges because they're straight edges. But the perimeter of a circle, because it's a curved object, we call it the circumference. We can find the areas of many geometrical objects with fairly simple formulas. So we'll have some formulas here. These are formulas that you can write down and jot to yourself to use on the exam. Big ones here are the perimeter of a circle is pi times diameter, or 2 times pi times r, because 2 times r is the diameter. And the area is pi r squared. You should be able to find the pi button on your calculator. If you have the TI-30X2S, then it's just directly above the exponent key on your calculator. And on the graphing calculator, I'll show it to you when I do a problem here later. So the area of a perimeter of a square is just 4 of the lengths, 4 times L, we add them up. And the area is just the length squared. Perimeter of a rectangle, 2L plus 2 width, we have 2 lengths and 2 widths. And the area is just length times width. The area of a parallelogram is still the perimeter of a parallelogram is still 2L plus 2W. And the area of a parallelogram is the length times the height, so we'll need this height. We don't actually measure the height at width W because that's an angled side. And then a triangle, the key one is the area is 1/2 times base times height. It's half the size of a rectangle. So let's say we have a window consisting of a 4-foot by 6-foot rectangle capped by a semicircle. and we want to know how much trim is needed to go around the window. So this blue stuff is the trim, and we need to know how long the trim needs to be so that we can buy the correct length at the hardware store, say. So what we need to do is figure out the length of the straight sides. So we have two 6-foot straight sides and one 4-foot straight sides. So if we add those together, 4 foot plus the two 6-foots, we have 16 feet. But then we also have the length up top, which is half of the circumference of a circle. So to know the circumference of a circle, we need to know its diameter, which is 4 feet. Okay, the diameter of the circle is 4 feet. So the circumference of that circle would be 4 times pi, but since it's a half a circle, we do 1/2 times pi times 4 feet, and we get 1/2 times 3.14 times 4 feet is 6.3 feet. I'll show you on the calculator where my pi button is. I would do 1/2 times pi, and the pi button is the second exponent key, second exponent, times the diameter, which was 4, and it's 6.3 approximately feet. Just be careful too when you're doing your homework to pay attention to what they want you to round the answer to. Okay, the total length of the trim needed for the window is about 16 plus the 6.3 feet, which was the length of the half of the circumference of the circle. Excuse me. And the total length is now 16 plus 6.3, 22.3 feet. Okay, let's say we have built a stairway in a new house and want to cover the space beneath the stairs with plywood. What is the area of this region? Well, this is pretty simple. This is a triangle, so it's just 1/2 times base times height. 1/2 times base times height, 1/2 times 12 times 9 is 54 feet squared. Remember, we're looking at an area, so this is feet squared, not just feet. Three-dimensional geometry. Two of the most important properties of a three-dimensional object, such as a box or a sphere, are its volume and its surface area. Volume is like, you think of like how much water can you fill it up with. That's the volume. Surface area is the area on the surface of the outside of the figure. So the table on the next slide gives the names of several familiar three-dimensional objects along with their volume and surface area. We have a cube, the surface area, the formulas are here. We have a sphere, a cube, prism, a rectangular prism, which is just a box, and a cylinder. And here are our formulas here. Now, the one about the cylinder, we have two elements as far as its surface area. When we look at the surface area of a cylinder, we have the two circles on the top and the bottom, and then the outside, which is actually just a rectangle. If we were to cut down the middle here and open it up, it would just be a rectangle. So the surface area formula has the two circles, which is the 2 pi r squared, because the area of a circle is pi r squared. So 2 pi r squared is the two circles, plus the area of the rectangle. Well, the length of this rectangle is the height, and the width of this rectangle is the circumference of the circle. And the circumference of a circle, if you know r, is 2 times r times pi. So this is the rectangular part, and this is the top and the bottom. Okay. Another example, water reservoir has a rectangular base that measures 30 meters by 40 meters and vertical walls 15 meters high. It was filled to capacity. At the end of the summer, the water depth was 4 meters. How much water was used? So we're definitely looking at a rectangular prism of a pool, and we're looking at the volume, length times width times height. So they filled this pool to capacity at 15 meters high, but then at the end of the summer it was only 4 meters high. So we used up 11 meters was used as far as the height. So that's what we're going to use to find the volume. Oh, they're going to do it this way. Okay, they're going to find the total volume at the beginning and then the water remaining at the end, and then subtract these two. So the amount used was this difference. If we did 30 times 40 times 11, it would be this answer. I'll show you. 30 times 40 times 11 is how much we used, and that's the 1320 or 13,200 that they meters cubed that they used. Scaling laws, just remember lengths are scale with the scale factor, like meters, inches, feet, yards. Areas scale with the square of the factor, so like meters squared, inches squared, yards squared, And then volumes are always going to be scaled with the cube of the factor. So inches cubed, meters cubed, feet cubed, yards cubed, stuff like that. So let's look at another example here from the homework. This cylinder. Okay, find the surface area and the volume of the cylinder. So an air duct in a stadium has a circular cross section, which means it's a cylinder, with a radius of 12 inches and a length of 31 feet. How much paint in square feet is needed to paint the exterior of the duct, and what is the volume of the duct? So when we have a duct, we actually do not have the circles covering it at the top and the bottom. They're open. So air can flow through the duct, or water can flow through the duct. So when we find this surface area, when we look back at our formula, let me find that PowerPoint here. When we look back at our formula for the surface area, we're not going to use this 2 pi r squared because it's a duct, and those parts, the two circles on the top and the bottom, are missing. So we're only going to use 2 pi times r times h to find this surface area. So when I do this, let me get the calculator in front. I'm only doing the 2 times pi times r. So 2 times pi times the radius, which is 12 inches. Oh, and it's a length of 31 feet, and it says I want this in feet squared. So I have to convert these 12 inches to feet. When we convert inches to feet, we divide by 12, so that's just, this 12 inches is just 1 foot. That's the radius is 1 foot. And then I multiply it by the height, 31 feet, and I get 194.77 or 78. It says round to the nearest hundredth, so that's the second decimal, so 194.78 feet squared. 194.78 feet squared. The volume, remember we have our volume formula right here. It's just pi r squared times height. The base is the circle. That's the pi r squared times the height. So remember, I have to use the radius as 1 foot and not 12 inches. So pi times r, which is 1, squared, times the height, which is 31. And the volume is 97.39 feet cubed. 97.39. Make sure I have that right. Okay. Okay, well, I guess they want the circles added on too, so I'll do that as well. That doesn't make much sense to me because it's an air duct and the circle shouldn't be there, but here we go. Okay, so let's follow the formula. They want me to add the area of the circle, so 2 pi r squared for the surface area, 2 pi r squared plus 2 pi r h. So 2 times pi r squared, so that's 1 foot, times 1 squared plus the area of the rectangle, which is 2 times pi times the radius, which is 1, times the height, which is 31. Gives us the total surface area of 201.06. Hopefully this is right. 201. Let me double check. 0.06. Interesting. Yeah, I would say that I don't really like this answer, but an air duct, I guess, has caps at the end, which is kind of stupid. But that's the end of the lecture. Make sure that you write down these formulas and you can use them on the exam. Good luck. We'll see you next time.